is Annika. I'm part of the Data Science Discovery team, and in this video today we will be doing a question on confidence intervals. So let's go ahead and get started. So here it says the sample mean salary of 15 NBA players is $70 million, and we also know the population standard deviation is basically $0.7 million. We want to construct a confidence interval for the population mean with 80% confidence. So now it says, what will be the length of our confidence interval in terms of millions of dollars, right? So here I have the formula written out for us, right? And basically, if you kind of look at this diagram here, right, our this middle line represents the sample mean, right? And then this, the number at this kind of tail here and this tail here will be our upper and lower bounds, right? If we are using our units in terms of the context, right? So basically the difference or the distance between the sample mean and the upper bound is our margin of error. This is why we have the plus or minus, because we want to find the sample mean minus the margin of error to get the lower bound, and then our sample mean plus the margin of error to get the upper bound, right? So if we want to know the length of our confidence interval, well, it's basically just the distance of our entire confidence interval from the upper to the lower bound, right? So it's basically just going to be our upper bound minus our lower bound, right? So the distance will be our upper bound minus the lower bound. Or if you look at the diagram here, it's actually just 2 times the margin of error, right? Which equals 2 times the MOE, right? Because that's this entire distance right here. So there's actually 2 ways to do this problem. I think using the 2 times the margin of error is simpler, right? Because you don't have to calculate the lower bound and the upper bound and then subtract them. That's honestly a bit redundant, right? You can just calculate your margin of error and then multiply by 2, right? I think that's a bit faster. So here, I'm actually going to kind of ignore this part, right, and just focus on the margin of error over here, right? So it's going to be MOE is going to be our Z. And what is our Z? Well, we know we're dealing with an 80% confidence level, right? So if I were to draw out a bell curve here, I know the area in the center is going to be 80%, right? Because that is my confidence level. I know this middle area will be 80%. So what is this upper kind of Z score here? Well, I know I can use norm.ppf to calculate that, right? And but we know norm.ppf accepts, like, given a percentile, what is a z-score? And the percentile is an area from like a point like all the way to the left, right? So given an area to the left of a certain number, right, given that percentile, what is a z-score? Well, we know the area to the center, in the center is 0.8, but we actually want to find this area highlighted in blue here, right? Because we want to input a percentile, right? Which is the area from this point all the way to the left, right? Well, we know the total area under our bell curve is going to be 1, right? So this means each of the tails is 0.1, which means this entire area here highlighted in blue is actually going to be 0.9. So we can find our Z by doing norm.ppf of 0.9. Right, and I can actually do that here using my programming interface. So norm.ppf of 0.9, and be sure to import norm from scipy.stats. So that's going to be around 1.2815. So 1.2815 times the standard sample standard deviation, right? So we know that we already have our population standard deviation of 0.7 given here, so let's just go ahead and use that. So we have 0.7 divided by our square root of n. So we have 50 NBA players, so that's just going to be square root of 50, right? So that's margin of error. So this is just one distance from the x to one of our bounds, right? We want to find the distance of the entire interval, so that's double the margin of error. So I basically just have to multiply this result that I get times 2. So this is going to be my final answer. And you can either, kind of do this on the calculator, or you can do it using Python, right? And if you want another way of doing it in Python, right? One way is to just kind of input all the variables and do the math like you would in the calculator, but in Python, right? Another way is actually to solve for the confidence interval in Python and then just find the distance using the upper and lower bounds. Maybe you can do that to double check your answer, or if you're running low on time, right? So, but I'm just going to give all the different techniques of how to solve this problem, right? So when I want to solve for a confidence interval using Python, I first want to define my distribution, right? What is the distribution I'm dealing with? Let's just call that D for our distribution, right? So D equals norm. I know this is a normal distribution, right, with a sample mean of 50, right? Sample mean of 50, and maybe we can do this here, right? Basically, our normal distribution for this confidence interval follows a mean of 50 and a standard deviation of 0.7 divided by the square root of n, right? Because remember, this is going to be using the standard error, right, which is going to be that standard deviation divided by the square root of n. So I cannot simply just put my standard deviation here for defining my normal distribution. My sample standard deviation is actually going to be 0.7. Sorry, my standard error will actually be my 0.7 divided by square root of 50, right? Because in our confidence interval formula, we use our standard error to calculate our final interval, right? So here it's going to be 0.7 divided by square root, the sample mean is actually going to be 7. My bad, I accidentally used n. It's actually going to be $7 million, right? So it's going to be $7 million is a sample mean, and 50 is our n. So 7 divided by 0.7 times the square root of 50. So it's going to be 50 to the power of half, right? So I have my distribution defined, right? And now I want to find d dot interval. That's the function that I'm going to use to find my confidence interval in Python. It's going to be d dot interval, and the argument we're going to put in is actually the confidence level. So it's an 80% confidence level, so I'll put in 0.8. And this is the final output, right? So this is going to be my upper bound, 7.12, and this is going to be my lower bound, around 6.87. So to find the distance, I can just subtract, my upper bound minus the lower bound. So you can either do that manually, 7.12 minus, just copy paste it and kind of solve for it here, which is 0.25, or you can assign the output of this d dot interval to variables. So you can, I know this returns a list, so you can just assign that to lower bound comma upper bound is going to be this, and then find upper bound minus the lower bound for my final distance, which should be the same, 0.25. So let me just go ahead and comment this out here. And when I run this again, yeah, it's the same, 0.25. So I just want to put this as my answer, and that is correct. So I hope this video was helpful. If you have any questions, let me know, and I'll see you next time. Bye.